Now we're going to take a look at a totally different way to solve systems of equations, and this is known as elimination. The goal here is that by manipulating the equations, we get one of the variables to eliminate, to get eliminated. Okay, so we're going to start with example Chilton, and I've got this system of equations. 5x minus 6y equals negative 32, and 3x plus 6y equals 48. And I noticed something right off the bat, and that is everything lines up perfectly. X terms line up, operations line up, y terms line up, equal signs line up, and the solutions, the constants, they all line up too. There's also something else I noticed. I have a negative 6y and a positive 6y. Well, what I can do is if I add these two equations together, that'll eliminate the y's. See, watch what happens here. Draw a line here, and I'm going to add the two equations. Look, 5x plus 3x is 8x. Negative 6y plus 6y eliminated because they equal 0. Bring this down, and negative 32 plus 48 is 16. So now I have simply 8x equals 16. Divide both sides by 8, and x equals 2. You see how quick that worked out? Of course, that's only half the answer. We still have to take 2 and put it into one of these two equations. Doesn't matter which one. Pick the one you think the arithmetic will work easiest. I'm going to go 3, so I'm going to use the second one, times 2 plus 6y equals 48. So that's 6 plus 6y equals 48. Take 6 away from both sides. 6y equals 42. Divide both sides by 6, and y equals 7. So the solution is 2, 7. That's how elimination works. You add or subtract the equations, one of the variables gets eliminated, and you can solve for the other one. Of course, now this example, we added the two equations. Let's look at how when you have to subtract is different. So this is example Luke's Diner. And again, everything's lining up. X terms, y terms, constants, equal signs, operations, they're all lining up. But what I notice is that these are both plus 8x's. So if I add them, I'm going to get 16, I'm sorry, not x's, 8y's. If I add these, I'm going to get 16y. Nothing gets eliminated. Well, if I can add equations, I can subtract equations. So we're going to subtract these two. Now, I just did something I would recommend against. See how I put the minus sign out here? What's going to happen is you're going to be working on a problem. You're going to drop the minus sign down. You're going to get distracted, and you're going to forget that you're subtracting not just the 4x, but the entire equation. So I always recommend you put the minus sign outside parentheses. Okay? Then just go through the operations. 2x minus 4x is negative 2x. 8y minus 8y is 0, got eliminated, equals negative 9 minus a negative 27 is actually negative 9 plus 27. That becomes addition, so we have 18. Minus a negative 27 is the same as adding, okay? Divide both sides by negative 2, and x equals negative 9. So we're halfway done. We have the x value. Which one of these do I want to put it in? Doesn't matter. I'm going to choose the first one. 2 times negative 9. So I'm taking the negative 9 and putting it in there. Plus 8y equals negative 9. So that's negative 18 plus 8y equals negative 9. I'm going to add 18 to both sides. 8y equals 9. Divide both sides by 8. And y equals 9/8, or 1 and 1/8, okay? It's okay if you're getting fractions. These do not have to be integer values. But my solution here is negative 9, 1 and 1/8. Okay? That actually is a good example of why sometimes doing it mathematically is better than doing it by graphing, because it would have been very hard to tell that the y value was 1 and 1/8 had we chosen to graph this to get the solution. Okay, so we had an example of adding and an example of subtracting. Now this one, and this is example Suki, solved by elimination. Now you'll notice everything lines up, but if I add, nothing gets eliminated. If I subtract, nothing gets eliminated. But what I can do is I can manipulate the equations by multiplying them. See, if I multiply 2 by 5, it also becomes a 10. So let's try that. Let's take this whole top equation, multiply it by 5. Now I can do that because when I'm done multiplying by 5, the left side will still equal the right side because I'm multiplying the entire equation. So this equation becomes 10x plus 25y equals negative 110. Yes, I did that right. I'm just going to slide the other one over. 10x plus 3y equals 22. Okay, now they're both positive 10y's, so I'm going to subtract. 10x minus 10x cancels, perfect. 25 minus, what happened to my y? What did you guys do with my y? 25y minus 3y, 22y, equals, now I have a negative 110 minus a 22, that is minus 132. Divide both sides by 22, and y equals negative 6. So I'm halfway there. Going to take this, put it into one of the two equations. Let's put it in the second one. So I've got 10, scratch that, 10x plus 3 times negative 6 equals 22. So that's 10x minus 18 equals 22. Add 18 to both sides, 10x equals 40. Divide both sides by 10, and x equals 4. So the solution is 4, negative 6. If I were to graph these two equations would intersect at 4, negative 6. Okay, one more. This time, what you'll notice is that there's nothing convenient I can multiply the top by to make it match the bottom, and like vice versa. See, up here, all I had to do was multiply one equation, and I got the 10s to match up. But there's nothing convenient here to multiply 3 by to make it 5, or 5 by to make it 8. Well, sometimes you have to multiply both equations. So the least common multiple of 3 and 5 is 15. To turn 3 into 15, I'm going to multiply the top by 5. And to turn 5 into 15, I'm going to multiply the bottom equation by 3. So the top equation becomes 15x plus 25y equals 150. Don't forget to multiply all the way over. And the bottom one becomes 15x plus 24y equals 147. Okay? Nice. Now look, they're both 15x's, but they're both positive 15x's, so I'm going to subtract. Oh, let me give you a hint. If you don't like the subtracting, instead of over here multiplying by 3, you could have multiplied by negative 3, which would have made that a negative 15 you'd be adding, if that works for you. Okay, so subtracting, 15x minus 15x eliminated. 25y minus 24y is simply y. And 150 minus 147 is 3. Well, that was easy. So we just take that 3, plug it into one of these. I'll plug it into the top one. 3x plus 5 times 3 equals 30. 3x plus 15 equals 30. 3x equals 15. X equals 5. There's your answer. 5, 3. Okay, so that's how you do elimination. You add or subtract. So the first example was adding. Second example was subtracting. Because you already have matching coefficients on one of the variable terms, sometimes you don't. Sometimes you have to multiply one of the equations, and sometimes you have to multiply both of the equations.